In number 9, we are asked to use the quotient rule, and I guess you might call them the definitions of cosecant and tangent. We're going to rewrite cosecant and tangent in terms of sine x and cosine x, and we're going to use the quotient rule to derive the differentiation formulas. Alright, so for the cosecant of x, remember that the cosecant of x is the same thing as 1 over sine x. So to find y prime, let's use the quotient rule, and we'll have the denominator times the derivative of the numerator, that's 0, minus the numerator times the derivative of the denominator, that's going to be cosine x, and that's going to be all over the denominator squared. So that's negative cosine x over sine x times sine x, and I'm going to rewrite this as negative cosine x over sine x times 1 over sine x. Now this is cotangent x, and this is cosecant x, and that is the derivative of the cosecant function. Now let's go on to the tangent function. Next we are asked to derive the differentiation formula for the tangent of x. So we will write this as sine x over cosine x, and then we will differentiate using the quotient rule. Alright, so the quotient rule tells us that the derivative is going to be the denominator times the derivative of the numerator, the derivative of sine x is cosine x, minus the numerator times the derivative of the denominator, and the derivative of the cosine is the negative sine, and then we will have cosine of x squared. So this simplifies into cosine squared x plus sine squared x in the numerator, and I hope you remember my favorite trigonometric identity, and that's that sine squared x plus cosine squared x equals 1 for any real number x. So you get 1 over the square of cosine x, but that can also be written as the square of 1 over cosine x, which would be secant of x squared, and we're done.